Okay, so the last thing in this set of notes was just this. That was the last thing. I had, what a mean, expected value, variance, standard deviation, and then I had just this data, table of data. So I'm just going to go with you from start to finish on StatCrunch, what it is you're supposed to do. So I put the table data on here. These are the random variables right here. These are must have been the outcomes. I don't know where this data came from. It said this was sales per day, and then this was the number of days. So evidently, so there were 16 days where there were 0 sales made. There were 19 days where there was 1 sale made. There were 2 days where there were 7 sales made. So I don't know what they're selling. Cars, maybe. I don't know. Houses, who knows what they're selling, but they're selling something. This was the number of days that had this many sales. So this is not a probability distribution. This is a frequency distribution. So in order to figure out what the probability is, because that's what I would like to put right here, I'd like to put the probability distribution right here. I want to fill this in, but remember I need to do, I need a total. So you need to add these up real quick. I can have StatCrunch do it. It's just summary stats on columns. Come over here and say I want to add the frequency and I want to find the sum. There it was. So it said the sum of all of those is 100. So this one, I believe I'm just going to be able to type in, I could be wrong, 16 divided by 100. I really wanted it to change it to a decimal. 19 divided by 100. 15. I don't like that. I wonder if there's another way I can do that. Delete. Okay, so I've researched it, and the best I can tell is I can't find a way to do it. So I'm just going to, I have my calculator here, and I'm just going to be using my calculator, whoops, to do, to turn those into, now I can't remember now where I was. So did I find this, the sum already? The frequency, the sum of the frequencies? Compute, that was 100. So it's 16 divided by 100. And I'm going to put that decimal value right there, 0.16. That's going to be 0.19. That's going to be 0.15. It's going to be 0.21. It's going to be 0.09. It's going to be 0.10. I don't think it'll keep the 0. 0.08 and 0.02. And this is going to be our probability distribution. So 0 and, the x values right here, and p of x, that's going to be our probability distribution. So we don't even need the frequency column anymore. I don't know. We can delete it, maybe. Let's just delete it. We don't need it. So these are the two that we need now. We've got the x value, the outcome, and we've got the probability distribution. And now we go to calculators, and we go over to custom calculator, and we pick the values are in x, the weights are in p of x, and I think we just compute. And when we do, this is what a histogram would look like. Remember, histogram is going to be bars that touch each other, so you would have to see these as bars, expand them out so that it's bars, but this is the general shape of the histogram. They're going to ask you, is it skewed? And this one is skewed to the right. Why? Because we have a longer tail on the right hand side. Here is the mean. The mean is 2.6. Here is the standard deviation. So if you wanted to see what the variance is, you would have to go to your calculator. I need to go back because I don't remember what it was, and do 1.9287,302. I don't have to put all of those in there, but I did just so that I get I don't have to worry about a rounding error. So I typed it in there and then I square it. And there, see, it gives me a nice 3.72. So that would be the variance of this data. One of the things that I want you to know that this down here is a nice way to calculate the probability. Now, you should be able to see if we go to equal sign right here, if we want to find the probability that you score a 2, it shows you right here that scoring a 2 is 0.15, but that should match right here. So if I were to take this probability distribution and I ask you, what's the probability? And what that would look like if it was written down would be this. It would look something like this. Uh-oh. It would say, I would say, what's the probability that x equals 2? That's exactly what it would look like. Just exactly like it's written right here. Probability that x equals 2 is 0.15. And what's the probability that x equals 6? 0.08. What's the probability that x equals 1? 0.19. So those are all of the exact probabilities. But if it said what's the probability that the score was less than, or these were not scores, what were these? These were sales. What was the probability that the sales per day was less than 3? So they're asking you here, sales per day, because that's what our table showed us. These were sales. What's the probability that you had less than 3 sales per day? So X is less than 3. Well, you have to know what they're asking about. Is having 3 sales per day less than 3? No. We would be talking about having 2 sales per day, 1 sale per day, or 0 sales per day. If you add all those up, you'll get the answer to this. Well, you don't have to actually add it up. You can come over here and you can change this to less than 3. And it tells you that you've got a 50% chance of having a day where you sell less than 3. 0.15 plus 0.19 plus 0.16. That's going to be 50%. 10, 20, 30, 40, 50. Yep, 50%. So this is very handy. I could ask you, what's the probability that you sell 4 or more in a day? So that would be the probability that you sell 4 or, that's not right. What's the probability that you sell 4, okay, or more? And you have to put a bar underneath it to represent selling 4. So that's the bar underneath it is selling 4, and then greater than means or more. So you would come over here and pick, so that means that what's 4 or more? 4, I keep forgetting to switch this. 4, 5, 6, and 7 sales per day is 4 or more. So you come over here and you change this to more or equal to, and you change that to 4, and you press compute, and now and it's showing you that in red that you add the 4, the 5, the 6, and the 7. So you add all those up and you're going to get 29%. So your the probability that you'll sell 4 or more or you'll make 4 or more sales in a day is 0.29. So those are the kind of questions that you might need to ask. I looked through your homework and I didn't see any homework, but that is definitely probably something that's going to come up on continuous. It didn't come up on discrete, but it will. But that's the kind of thing that you can do. That's why that's down there. It allows you to find those different probabilities. You don't have to have this to do it because it would be the same thing as you just adding these up together, but that's how you handle it on StatCrunch. Anyway, I'm done.